Good afternoon, students. So let us start with our today's class. That is, we are going to start with the second section. That is, second section of the data science and data science subject. So within the first section, we have seen the three chapters, and in the second section also, we are having three chapters. So in the first section, we have seen what is meant by a data science concept. Then next, we have seen which are the tools which we can use in the Python. And in the third chapter, some of the mathematical foundations regarding probability, linear regression, and hypothesis we have learned. So now we are starting with the actual machine learning. So here you might be thinking that why we should go for the machine learning. So because here, when it comes to data science it means that how my figures are getting affected. That is completely dependent on the data. And just like data science, machine learning is an application of the data science concept. It means that here, after learning the science between the data values, then we are designing machine learning algorithms. So here we can see that these fields are overlapping with each other. So not only machine learning, we are having other fields also which are there in the data science. But right now, the second section is about machine learning. So initially, in the first, that is fourth chapter, we will be learning machine learning. That is a few of the classifications and regression techniques. In the fifth chapter, we will be learning machine learning algorithms. That is, there are six main algorithms which are required for the machine learning. And whenever we are building any of the model or any of the application for machine learning, either of the six model can be used. That is, most widely used algorithms are there. And in the sixth chapter, we are learning about the case studies of the machine learning. So let us see the details of the machine learning. So this is the syllabus. So first point is regarding overview of the machine learning concept, that is overfitting and train and test splits. Then next we are having types of machine learning, that is supervised, unsupervised and reinforced learning. Fourth one is regarding introduction to Bayes theorem. And last one is regarding linear regression, that is where we are performing model assumptions and regularization. So again, there are three techniques: lasso, ridge, and elastic techniques. So let us start with the introduction. So these are the 4 points we are learning. So this seems to be 4 points, but here, whatever this types of machine learning are there, this is the main point which we are going to learn here. So what is meant by supervised learning, unsupervised learning, and reinforced learning? So let us start with the syllabus. So let us see first why we are learning machine learning into the data science. So here it means many people imagine that data science is mostly machine learning only, and data science mostly build and train and tweak machine learning models all the day long. Yes, that is true. But in fact, data science is mostly turning business problems into data problems. So here, data science, mainly we are focusing on the growing the business or enterprise success. And for this purpose, business might be facing some problems. So whatever the problems we are looking at or whatever the problems the business is having, those are converted into data problems. Here, now we again turned into the figures. That is, we will analyze the root causes of those problems and root causes in terms of some variables or some characteristics or some data values. For example, if consider here ratings are less or quality is low or etc. So these might be the problems, but when it comes to data problems, so here we will be talking about the features. That is, because of which this product or because of which this product is not liked, etc. So it means that whatever the problems business problem are having, we are converting these problems into data problems. Then collecting data, that is why that is a failure of the data. That is business problem is there, then we collect the data. What is the exactly problem? So then in terms of problems, we collect the data, then understand data, why those problems are there, then cleaning data and formatting data. It means that here we will be learning wherever the lacunas are there, that we are talking about. And after which machine learning is almost a afterthought. It means later on we will decide that how we can solve this problem. And for this purpose, the machine learning concept is used. So here it means that data science we are applying here through machine learning. Okay, so that's why we are having data machine learning as a complete second section in our study. So the first point is overview of the machine learning concept. Within that, we will be learning two concepts, that is overfitting and train-on-test splits. Okay, so first let us see which are the concepts of machine learning you wanted to learn. So first one is a model. So what is meant by a model? Model, it means that what are the features I'm having related to my product or like anything else for which purpose I'm having my business. I if we are putting that values into some mathematical formula, or if I'm establishing or specifying the mathematical relation between these different variables or features, then that mathematical relationship is called as a model. Okay, so model, it means that it is simply a specification of mathematical or probabilistic relationship that exists between the different variables. So, okay, for example, if consider that initially, in order to grow my business, whatever the raw material I'm taking, for this purpose, initially I was spending consider 10,000, and now I wanted to improve my quality, and because of which whatever previously I was taking some raw material, I increased the quantity, and from that I take up the only quality product or quality raw material. Then here it means that if I'm taking this much raw material, and from that if I'm removing the wastage and then I'm extracting only this much uh, raw material, that is quality raw material, and then I will check how my product works. So it means that here if I'm talking about input and output terms, then I'm building a model. That is, if I'm able to establish a relationship between those variables. So that is a model. So the business model is probably based on simple mathematical relations. That is, profit is revenue minus expenses. So here it means that whatever my input is there and output is there. If I wanted to calculate the profit, then output minus input, whatever it is there, I can say that is my profit is there. So revenue is units sold times average price and so on. So it means that I cannot say that if today I invested this much money, consider that 10,000 I invested today, and after 2 years I got only 11,000. Then it means that I got a profit of 1,000. But whatever the price is there and how much unit has passed, also how many units of products are sold. So here average price, etc. So here if I wanted to calculate how much profit I am gaining, then in case of units sold time average price, that is within how much time we sold that, etc., that also matters here. So we cannot guess that today I invested my 5 lakh rupees and after 10 years I'm getting only 5 lakh and 50,000. No, in that case I can say that the whatever the times average price is there, I cannot afford that, or that is not an expected result. So here the time duration also we are specifying, and unit sold also we are specifying. And if I wanted to calculate that, yes, today I invested my 10,000 K or 10,000 rupees, and after a month I'm getting 20,000. Then whatever my 10,000 are there, I wanted to calculate how much price I'm having. Or I wanted to gain, if I'm investing my 10,000, then I wanted my 15,000 to be my outcome. Then here, after passing the 10,000, how much average or how much input I wanted? So 15,000 I wanted. Then within that, if I'm having the 1,000 products, then within the 1,000 products, how I should apply the price so that I can get the 50,000 as my profit, 50,000 as my output. Then that is also calculated here. So here business model contains these values. That is, what is my investment or what is my input, then how much expenses we are maintaining, and then how much profit we are getting, and what is the average price, etc. So these are the facts which we are considering during the business model. That is, we are talking about a mathematical relation here in terms of business. Then next, what is a machine learning? So this is regarding a model. That is, I wanted to introduce the concept of model. Then let us see what is meant by a machine learning. So machine learning mainly refers to creating and using models that are learned from the data. Okay, so this refers to be quick, but this is the shortest or required definition we can say. So machine learning refers to creating and using models that are learned from the data. So here, if consider we wanted to learn from the data, it means that initially you need to process this much data. On that data, we need to apply much more formulas and then check whether I'm getting required profit or not, whether this much I'm expecting I'm getting this much or not, whether these features are used on this feature, am I getting any result? If I'm improving this feature, whether my uh, values are getting changed or not. So here it means that whatever data is there, we are we wanted to find out the relation between the data values, or we can say the variables or properties, and from that we will build a mathematical relation, and building that mathematical relation or model is nothing but a machine learning. Okay, if I'm passing this much input and after I will get this much output, then what are the in between formula is there, that is a model, and that model building is called as a machine learning. So sometimes this is also called as a predictive modeling or data mining as well. Okay. So here, what maybe we are requiring for the modeling? It means why we need to model the data. So here, our goal is that to use existing data to develop models that we can use to predict various outcomes for a new data, such as predictive whether an email message is spam or not. Okay, the next, whether predicting whether a credit card transaction is fraudulent. Next, predicting which advertisement a shopper is most likely to be click on. Predicting which football team is going to win a Super Bowl, etc. It means that, so these are some predictive models or predictive applications or applications of machine learning where I wanted to use on existing data to predict the future or predict the next outcome. Okay, so that I can take my corrective steps. Okay. So take a look at this slide for a minute, then we'll go for the next slide. So machine learning mainly is that using the model or creating and using the model that are learned from the data. From data, if we are building some model, then that is a nothing but a machine learning. Not only this, not only prediction, for hypothesis also, that is prediction, it means that probability we are guessing. So in hypothesis also we can use inference, etc., machine learning. So these are the few of the normal applications, or most widely we can say. Okay, this applications of the machine learning are there. So next, let us understand the concept of overfitting. Okay, so here, uh, this model it means that we wanted to give a mathematical relationship exists between the different variables. Okay, different variables here I'm referring to different features, different data values. Just like in the class we have taken example of the chair. In the chair I'm having color, I'm having height, weight, etc. It means these are the different values, and based on that other values might be there, but we have taken example of this. So we are referring how much people will like that, or what can be the criteria. Just like if I say that that is having minimum weight, that is weight, I can say that that is a formula. So it means that is a variable which is holding some value, etc. Okay, so here we are learning about the overfitting concept. Actually overfitting, this is one concept. Generally, there are three concepts: generalized, overfitting, and underfitting. Okay, so let us see. So these are the concepts actually used in terms of the supervised learning, which is our next point in the syllabus. Okay, actually this is first point. And in the second time, we are learning supervised, unsupervised, and reinforced learning. And in supervised, actually this concept is used. But let us see. In short, we will explain the supervised learning, and then we will go for the overfitting concept. So, okay, in case of supervised learning, uh, first, what is meant by supervised learning? Supervised learning, it means that initially we are passing some training data, and then some untrained data is there. Uh, for example, I will go to the new slide. Consider that I am having 100 samples of my data, okay, and I wanted to perform the classification, and for those 100 samples, and for these 100 samples I'm having considered 10 features. Okay, 10 features, it means that 10 properties are there, or 10 different values in terms of matrix or vector are there. Okay, classification, it means that if I'm taking my training data of 100 samples, then I know that out of these 100 samples, which one belong to which category. Classification, it means that I wanted to divide these 100 samples into three classes. Okay, consider that this 100 samples I wanted to convert into or divide into three classes. Then initially whenever I'm training this data, training म्हणजे काय की मी अजून माझा मॉडेल बिल्ड केलेला नाही. I had not built my model. Okay, here I know that out of these 100 samples, how many belongs to first class, how many belong to second class, and how many belong to third class. Class म्हणजे काय की मी यांना कुठल्या तरी कॅटेगरीच्या बेसिसवर डिवायडेशन करते यांचं, or I'm dividing these into three classes based on the properties or these features. Okay, so here classification, here if initially whatever these 100 samples are there, I will also have a label here. Label, it means that my first sample belong to class 3. My second sample belong to class 1. My third sample belong to class 1. म्हणजे मला माहिती असते की या 100 सॅम्पल पैकी कुठला सॅम्पल या तीन क्लासेस पैकी कुठल्या क्लासमध्ये आहे. Okay, so that's why I can say that here we are passing a labeled data. Labeled data initially before the input, I know that out of these 100 samples, how many will belong to the first class or second or third. So that is called as a labeled data. So supervised learning, what it will do, it will perform the study of this or training those 100 samples and will design a model, will design a mathematical relationship on these 10 features. Okay, and after designing the model, other it will take 50 more samples. Here, except it means not this only 100. Other than this 100, there are more 50 samples are there. Here, training data is there. It means that on the training data, we are building a mathematical relation. म्हणजे या 100च्या सॅम्पलवर या 100 नुसार कुठला फॉर्म्युला लिहिल्यानंतर माझा तो सॅम्पल माझ्या फर्स्ट क्लासमध्ये जाईल. म्हणजे बरोबर की मला हा पहिला सॅम्पल थर्ड क्लासमध्ये घालायचा आहे. म्हणजे मला त्या कुठल्या फीचर्सवर फॉर्म्युला लिहिल्यानंतर मला हे याच्यासाठी क्लास 3 दाखवेल, याच्यासाठी क्लास 1 दाखवेल, याच्यासाठी क्लास 1 दाखवेल, सॉरी सेकंड सॅम्पल क्लास 1 मध्ये जाईल, थर्ड सॅम्पल माझं क्लास 1 मध्ये जाईल. म्हणजे मला जर समजा हे जर अचीव नाही करता आलं तर मी माझा मॉडेल चेंज करत राहील. Okay, so here 100 samples I am providing and those are the labeled samples. Labeled samples, initially I know in which class these samples are there. So my input will be the sample, and sample it means that these 10 features of my sample, and output will be in which class my sample will go, either first, second or third class. If consider I'm giving the correct class, it means that my model is working properly. If consider initially I designed my model and instead of giving the first sample, consider for the first sample, it is actual class is third and it is giving me other than three, first or second, then I can say that my model is not working properly. Okay, clear with this? म्हणजे कळतंय का कुणाला काय चाललंय ते? हिअर माझ्याकडे जे सॅम्पल आहे, ओके, त्या सॅम्पलच्या बेसिसवर मी ठरवलं की या सॅम्पलचा क्लास कुणाचा कुठला कुठला असू शकतो. तर माझ्याकडे डेटा आहे की माझा फर्स्ट सॅम्पल जो आहे तो थर्ड क्लास मधला आहे, सेकंड सॅम्पलचा जो आहे तो फर्स्ट क्लास मधला आहे, and third sample जो आहे तो पण माझ्या फर्स्ट क्लास मधला आहे. So it means that this will be my input and 3 should be my output. This should be my input and this should be my output. This should be my input and this should be my output. So sampleचं input म्हणजे काय की माझे हे 10 features, 10 properties of the each of the sample. मग हे जे फीचर्स मी इनपुट करून घेतलेले आहेत, सो मॉडेल इट मीन्स दॅट आय एम हॅव्हिंग अ मॅथमॅटिकल रिलेशन हिअर. सगळ्यांमध्ये मी काहीतरी मॅथमॅटिकल रिलेशन बिल्ड केलं, एक्स वाय झेड प्लस ए बी इक्वल टू 1 2 3 4 or x square y square etc. It means any mathematical relation I build. Then other than that, if consider समजा मी हे फर्स्ट सॅम्पल साठी माझा आला आउटपुट करेक्ट आहे, याच्यासाठी पण माझा आउटपुट करेक्ट आहे, देन आय कॅन से दॅट माय मॉडेल इज वर्किंग प्रॉपरली. देन दिस विल बी कॉल्ड एज अ ट्रेनिंग डेटा. ट्रेनिंग डेटा म्हणजे काय की माझा मॉडेल बिल्ड करण्यासाठी मी एक्झिस्टिंग लेबल्ड डेटा त्याला दिला की बाबा हो हे असं होऊ शकतं, हा मॅथमॅटिकल फॉर्म्युला बिल्ड होऊ शकतो याच्यातून, आणि या मॅथमॅटिकल फॉर्म्युलामध्ये व्हॅल्यूज टाकल्या की मी माझा बरोबर क्लास show करते. And here, so this is called as a mathematical build-up formula and this is called a training data. मग त्याच्यानंतर मी 50 samples घेतले, okay, other than this 100, and whatever model I have built, to that I have given this 50 samples. Okay, if consider for each of this म्हणजे 50 samples साठी पण याला classification correct, then that concept is called as a generalize. Generalize, it means that I'm writing some general formula and it is giving me the correct answer. Okay. let me move to the point now. So clear with this, what is mean by sample data, what is mean by model, what is mean by generalized. Here, whenever we are talking about overfitting, so here, uh, let us go from the start. In supervised learning, we want to build a model on training data and then be able to make accurate predictions on new, that is training data म्हणजे माझे initial 100 samples and new data whatever new 50 samples I have taken, unseen data, okay, unseen data which is not previously processed into my system has same characteristics as the training set that we used. Yes, here the meaning is that it should not happen that whatever the 50 samples I'm taking, okay, whatever the 50 samples I'm taking, each of this is having the 50 feature, 20 features. No, here if I'm having the 10 features, same 10 features should be held by the 50 new or unseen samples. Okay, तेच 10 feature माझे या 50 सॅम्पलचे सुद्धा असावे. So it should have same set of the features. Characteristics are the training set that we have used. If a model is able to make accurate prediction that if class is 2, it should answer me 2. If class is 3, it should answer me class 3 only. If it is able to make accurate predictions on unseen data, we say it is able to generalize from training to the test data. Okay, so whatever this training data we have seen and whatever the new unseen data we have seen, so unseen will be called as the test data. Test data, again I wanted to check for these also. This is giving me the exact or correct answer. So this will be called as a training data and this will be called as a test data. Then we want to build a model that is able to generalize as accurately as possible. Okay, so whatever model we wanted to build, this mathematical relation that should be correct or accurate. Accurate it in the sense that for 100 samples, it should give me the correct answer. And for 50 samples also, it should give me the correct answer. Yes, it is a human, that is human is building the codes or human might be providing the features. So we cannot guess that 100% accuracy is there, but we are expecting that 99% the accuracy should be there. Okay, so overfitting, it means that whatever training data we have given, for the training data, my model works properly. But when there is a new data, it doesn't work properly. Okay, so overfitting occurs when you fit a model too closely to the particularities of training set and obtain a model that works well on the training set but is not able to generalize to the new data. Okay, so whatever the new data values are there, for that purpose the model doesn't work properly. Then we can say that that concept is called as a overfitting. So here, if consider we are going for the simple formula, then simple formula may not give the correct relation, but when it comes to the complex formula, then it will work much more proper. Okay, so first read the definition of overfitting. Okay. Here, overfitting it means that here on the training data, my model works, but when there is a new data, it may not be able to go with the same flow. It may deviate. It means it will not give the exactly same results. So for this purpose, we wanted to build a model which will be complex, but it should give me able. It should be able to predict the better. It should make the better prediction. That is, whenever I'm giving a test data, it should give me the proper answer. So if, but there might be a problem that if our model is too complex, then we may not be focus on the individual training data. So we may not be able to generalize the new data as well. Okay, so here is a figure which explains this. Okay, so here this is just a figure which mentions what is called as a overfitting, what is called as a generalization, and what is a training. What is a overfitting? Okay, so here I wanted to check the accuracy. Accuracy, it means that here sweet spot, this is the spot at which my training data ends and test data starts. Okay, so sweet spot at which we started learning that our data is not actually working with the existing model. So underfitting, it means that here I'm building too complex model. That is, it is not giving me the proper answer. Underfitting, it means that I'm unable to collect all the data points or mention. Okay, first, here, this is my training data. Okay, the blue line says that it is a training data. So as per the training data, I'm giving this curve. That is, if model, this complexity, here this is increasing, and here I'm showing the accuracy. Okay, so for the training data, whatever values I'm passing, based on that, this is the graph which I'm getting as a output. That is, whatever complex inputs I'm giving, for this I'm getting this output. And generalization, it means that here the actual values in supervised learning, we always have a labeled data. Labeled data, before giving the input, I know that what is a in which class my new data or test data will be there. So here I can see that at the initial level, this is working properly, but as it is crossing the sweet spot, that is, it is deviating. Deviating म्हणजे माझा कर्व बदलला or जो काय actual normal behavior आहे त्याच्याकडून मी divert झालोय. So that is called as a deviation. So from this sweet point, I started the deviation. So generalization, it means that this is expected. The green line is expected. But overfitting म्हणजे काय की ट्रेनिंग सोबत हे ओव्हरफिट करतं. ट्रेनिंगच्या दिलेल्या मॉडेल नुसार और ट्रेनिंग डेटा जो दिलाय त्यानुसार माझा मॉडेल सांगतो की दिस विल बी द परफॉर्मन्स. माझ्या व्हॅल्यूज अशा असू शकतील. बट जनरलायझेशन ऍक्च्युअल माझ्या व्हॅल्यूज अशा आहेत. सो दिस इज कॉल्ड एज अ ओव्हरफिटिंग. माझं जे ऍक्च्युअल कर्व आहे त्याच्यापासून माझं डेव्हिएशन चालू झालं. Okay, so this is called as a overfitting. Overfitting, in case of training data, my model works properly, but when it comes to the test data, it doesn't work that much properly. And for this purpose, we need to design a much more complex formulas. So here, this is an example I have taken. Actually, this is from the textbook. So here, we are having the features like age, number of the cars owned by the person, whether the person owns a house, number of the children of the person, marital status, owns a dog. Yes, these are the features of my clients, or we can say the customers. And I'm checking whether this person has bought a boat or not. Okay, so here, consider that I'm having the boat company and I wanted to analyze who are my customers. Okay, so when I wanted to study, so initially here I come with the rule that if customer is older than 45, okay, मला बघायचं की माझी boat or who has taken or bought a boat, then in order to say or recognize the rule, what is the rule? If customer is older than 45 and has less than 3 children, or it is not divorced, then they want to buy a boat. Okay, so let us see whether this rule is followed by how many people. Customer is older than 45, so we will check those who are older than 45. Then we will check the children criteria, and we will check the marital status, and then we will check whether that person has got the boat or not. If this is my formula or this is my model, then we will check how much accuracy is there. Okay, 45 age, yes, this person is greater, has less than 3 children. It means 2 is correct. Not divorced. So not divorced, widow doesn't mean not divorced. So we will consider this. And yes, this person has got, it means this value or this record satisfied this rule. Then next second, 52 value greater than 45. So this person doesn't have the children less than 3. So it means we will skip this rule for this person. Then we'll go for the next person who is having age greater than 55. So 53 is the age. Yes, uh, the person is having age greater than 55. Children are less than 3, not divorced. So again, we cannot say that that person had not bought boat. So we will skip this. 64, no. 58. Yes, the status is married, children are less than 3, age is 58, and this person has bought the boat. So it means that this rule is applicable to the 100% accuracy. That is, if we talk about this current data set and have checked how many tuples or how many existing record which satisfy with this, how many has got the boat. So I guess that this rule completely get follows or accuracy of this rule is 100%. Now, next rule is people older than 50 want to buy a boat. Okay, so this if I'm talking about older than 50, yes, 66 is that he has so now here main difference is that this is complex formula and next one is much more easier. So we wanted to say that if complexity is more generalization will be there. And if complexity is less, overfitting might occur. Okay. So here above 50, this one is there. Yes, he has got 52. This person has also bought the boat. Then other than 50, 53, 53, this has also bought the boat, and 58, sorry, 64, 64 had not bought the boat, and 58, this has bought the boat. Okay, so it means that here, when it comes to the accuracy, out of 5, okay, out of 5, there is only one person which does not satisfy this rule. Okay, still, when it comes to the, it means 5%, 20, 1% out of 5, it means that 20% deviation is there. So it means that even though if I'm stating this complexity, so it means that I'm getting the 100% accuracy. But if I'm reducing the complexity, then I'm getting the 80% as a correct result. So it depends which one application you wanted to build. So curve for this will give same as generalized, and curve for this will show the deviation from the generalized. Next, train or test the splits. So the same point we are continuing here. So train and test split procedure is used to estimate performance of machine learning algorithms when they are used to make predictions on data not used to train the model. Okay, so here we are talking about how much training data should be there and how much testing data should be there. Okay, it is a fast and easy procedure to perform. That is, we wanted to divide among this. So the results of which allows you to compare performance of machine learning algorithms for predicting modeling problems. Although simple to use and interpret, there are times when procedure should not be used, and such as when small data set is there or very less data sets are there, values are there, and we are unable to produce the data set, then wherever configuration is required for this purpose, this is not used. But mostly train data, we are taking 30 to 40% training data, and test data will be removed. Okay, so as much complex we will have a training data, that is variety of the training data, that much perfect model can be built. Take a minute reading methods. Okay, now what we have learned? We have learned regarding overfitting, underfitting, and generalize of curves, or we can say the data sets. When what is meant by machine learning? That is building a model which establishes a mathematical relation. And this example for the overfitting we have seen. The next, what is meant by train and test splits. So now let us go for the next point, that is types of machine learning. That uh, is how the machine learns the model, or how we wanted to build a model. So there are three types of the ways are there, that is supervised, unsupervised, and reinforced learning. Okay, before that again we wanted to learn what is meant by labeled data and unlabeled data. Okay, as with any method, there are different ways to train machine learning algorithms, each with their own advantages and disadvantages. So out of these three, it depends of which one we to use based on the application. So to understand pros and cons of each type of machine learning, we must first look what is kind of data they can digest or ingest. It means what type of data or which type of methodology they use for the machine learning. So in ML, there are two kinds of the data, that is labeled data and unlabeled data. So let us see what is meant by unlabeled data. So a labeled data has both the input and output parameters in a completely machine readable pattern, but requires a lot of human labor to label the data to begin with. Okay, so if considered as per the previous example, if I'm talking about this 100 samples where consider that I wanted to decide for the classification. So giving the label or deciding, समजा मी 100 ऑब्जेक्ट जर दिलं आणि त्याच्यामध्ये प्रत्येकाच्या प्रॉपर्टी घेऊन जर समजा सांगितलं की 3 क्लासेस मध्ये डिवाइड करा. So it means that whatever this labeling is there, whether this object belong to 1 to 3 class or either which one of the either class, that is a difficult task. Okay, and that is initially a primary task for the supervisor. So for this for labeling, human label is required. The next, unlabeled data so only has one or none of the parameters in machine readable form. This negates the need for the human labor but requires a more complex solution. Okay, so unlabeled data, it means that we don't know in which class out of this 1, 2, 3, 4, in which class this uh, in which class that data or that object can fall. So it means that here, whatever the 10 features we are studying, then all these will be in machine readable form. That is, those values will be stored. And this negates the need for the human labor, but requires more complex solutions for that. So, fine. Okay, so up to this point only we will study today. So, are you clear with the labeled and unlabeled data? Any doubt in the previous points, whatever we have learned? Any doubt in the previous points? Overfitting, generalized, underfitting. What is meant by machine learning? No doubt. Then please stay online. I will take the attendance, and then after taking the attendance within the next 5 minutes, you can leave the meet. Okay, but please be in the meet only. Timing. If you are having a doubt, you can ask